Maayong adlaw mga bata! This is again Teacher CJ, your tutor of the day. In this video tutorial, you will be taught on how to prove and disprove statements. Mamomotivate kayong patunayan kung legal son ba kayo, legal daughter ba kayo, or legal wife kayo. So ano pang hinihintay nyo? Patunayan nyo! Na hindi siya ang karapat-dapat. Kayo yun. Alam niyo ba na may mga significant statements na tayo katanggap-tanggap na at pwede nang hindi na patunayan pa? Ito ay ang mga theorem, proposition, lemma, at corollary.
Today, let's discuss Lesson 6 on methods of proof and disproof. There are three types of statements. There are statements that are known to be true, the statements that the truth is unknown, and a statement in which it's known to be false. Say for example, the square of an odd number is odd. In this statement, it is known to be true because if we will try to square an odd number like 3 squared is 9. 5 squared is 25. So 9 and 25 are both odd numbers. If the statement is all perfect numbers are even, here the truth is unknown because if you will say 25, that is a perfect number and the number is odd. If 9, the number is odd. If 16, that is a perfect number and the number is even. So the truth is still unknown. The third one is all prime numbers are odd. This is known to be false because 2 is the least prime number and that is even, so it is not odd. Therefore, the statement is known to be false. We also have here the Goldbach's conjecture. Every even integer greater than 2 is the sum of 2 primes. So greater than 2 are the even numbers 4, 6, 8, 10, 12, and so on. So if you're going to see the sum of 2 primes of 4, we can have 2 and 2. In 6, we can have 3 and 3. In 8, we can have the prime numbers 3 and 5. In 10, we have prime numbers 3 and 7. In 12, we have 5 and 7 as prime numbers. In 14, we have 7 and 7 as prime numbers. So we can see that the even numbers greater than 2 is the sum of 2 primes. This Goldbach's conjecture was a statement from Christian Goldbach last year, 1742. So conjecture is accepted without further proof. Hence, it is proven true in the examples that we have showed. Example, we are given this argument, P or not Q, R or S, Q and not R, and our conclusion, which is P and S. The first thing that we will do to create a truth table is to count the number of variables used. We have P, Q, R, and S. So we have 4 variables. Then we will raise 2 to the power of 4. So 2 times 2 is 4, times 2 is 8, and times 2 is 16. So we have 16 rows. We divide 16 rows into 2. So we have 8 rows. 8 rows will serve us the true statement for P, and 8 rows will serve us the false statement for P. Then we will divide 8 rows to 2 to get Q. So 8 divided by 2, we have 4 rows for true and 4 rows for false.
In alternate way.
In Q. Also, we have 4 rows for true. We divide it into 2 to get column R. So we have 2 rows for true and 2 rows for false arranged
in alternate way.
in S. We have T and F, and we'll write it
In alternate way.
for not Q. We will just negate Q here in the second column to the fifth column. So the negation of true is false, the negation of false is true. Also, in not R, we will get the negation of R in the third column, and that's in the sixth column. So the negation of true is false, the negation of false is true. In the premise, we have first, second, and third, and also the conclusion. We can see here a row which are all true. We have the third row. So this is what we are referring to in our first topic on proving of arguments. It is considered valid since the conclusion is true and the premises are all true. In fact, using the truth table in validating argument is time-consuming when the argument includes 3 or more propositions. The truth table does not give the exact idea why a given argument is valid or invalid. So here, you will learn the different methods that can be used in systematically establishing validity of an argument, which is called proof. So you will learn here how to prove validity of arguments in propositional form. In the first example, we need to prove the validity of the following argument. We have the first, which is P, the second, which is not Q implies not P, the third, which is Q implies R, and the conclusion is R. So in the first proposition, we are given the premise not Q implies not P. In the second, we will just get its reverse and then get the negation. So P implies Q is true contrapositive 1. In the third one, Q implies R, it's also a premise given in the example. In the fourth one, P implies R. We get this through hypothetical syllogism 2 and 3. So we have P implies Q and Q implies R is just P implies R. In the fifth proposition P, that is also given in the example, which is a premise. Through modus ponens 4 and 5, we have P implies R and P is just R. In the second example, we're going to prove the validity of the following argument. We have the first one is A implies B, the second one is C implies D, the third one is not B or not D, and not A or not B. And the conclusion is not A or not C. So in our proof, we're going to use a table involving the proposition and the reason. So in number 1 proposition, that is a premise which is given in the example. Number 2, C implies D is also a premise in the example. The third one is through conjunction 1 and 2, which is in conjunction, a proposition is the result of combining two other propositions called conjuncts with the connectives word and. So we are going to combine the first one and the second one through and. The fourth one is also given in the example, which is considered a premise. The fifth one is through simplification from statement 3, which is not B or not D. And the last one, in proposition 6, we have proven that not A or not C is through destructive dilemma 3 and 5. Since the fifth proposition says that not B or not D, meaning not A or not C, is true also. So aside from showing the proof, we can also show the disproof. What is the difference between disproof and proof? In a proof, you can show that it is true. However, in disproof, we can show that the statement is wrong. So in the example, if I enter the poodle den, then I will carry my electric poodle prod or my can of mace. If I am carrying my electric poodle prod but not my can of mace, therefore I will enter the poodle den. So how to show the disproof of this? We should also symbolize the argument. We are given the first statement, if I enter the poodle den, let's symbolize this as argument P. I will carry my electric poodle, let's symbolize this as Q, and S as I will carry my can of mace. We reduce the argument to its propositional form, so P implies Q or S, then Q and not S is just P. Let's try to show this one using a table. We have PQS as the variables, so we'll have 8 rows, which is 2 to the power of 3. So we get Q or S, and P implies Q or S, and also not S in the first premise. In the second premise, we get Q and not S. Also, P implies Q or S, and Q and not S. In the conclusion, we also show that P implies Q or S, and Q and not S implies P. So here in the table, we have shown that this is a disproof because the statement in premise 1 is true, the statement in premise 2 is true, while the conclusion is false. Therefore, this is a disproof. The result is false.
Alam kong marami kayong natutunan sa tutorial na ito. Maraming salamat sa pagkikinig at paalam hanggang sa susunod.